In number 3, we're going to take water at 25 degrees Celsius and heat it up to steam at 125. So I'm going to do kind of just a little heating curve here. And so it's water, so that's going to be at 100, that'll be at 0. And then my substance is starting at 25, so it's going to be somewhere in there, but it's in the liquid state is where it's starting, and it's going to be ending up here at 125. So for each segment of the heating curve, you're going to have a different calculation of Q. So we've got Q total, and now it's going to be equal to the Q, and I'll just put an upward arrow, meaning to increase the temperature of the liquid, plus the Q to vaporize, plus the Q to increase the temperature of the gas. So that's my little shorthand that I use. Now, so each of those Q's will have a value associated with it, and so we've got the Q to increase the liquid is going to be mass, specific heat of the liquid, delta T of the liquid. The Q to vaporize is going to be the mass times the delta H of vaporization. And then the Q to heat the steam is just going to be mass times the specific heat of the gas times the delta T. Okay, so we're going to plug in some numbers. I'll just come down here where I have more room. And so my mass was 200 grams. So for the first piece, I have 200 grams. The specific heat of liquid water is 4.18. And then my delta T is T final minus T initial. So my final for this segment there, right, is right there at 100. So 100 minus 25. Okay, and then now I'm on to the next one. So the Q to vaporize is going to be the 200 grams. And the heat of vaporization is given as 2,260. And then the Q to increase the temperature of the gas is again going to be 200 grams times the specific heat of the steam, which is 2.01, and the delta T of the steam, it's going to end at 125, and it started at 100. So when I put all that together, I get 524,750 joules.